Hello everyone. Can anyone confirm if audio and video is fine? I was able to solve six problems A to E and G. So I am planning to discuss these six problems, and probably that's the idea. I had some idea on F, but in the end I realized that should give me a W and even failed on samples there. So yeah, I will go in order from A to E and G. Before we get started, can anyone confirm if audio and everything is fine so that we can be live? And by the way, people in the chat, how many problems were you guys able to solve today? Okay, four E kick for this. Okay, I'm not. Yeah, E has appeared quite a lot of times, to be honest. So I'm not surprised. You did not find it on Google. So that's the idea I have. Okay, solve 5, 3, etc. Okay, so I think we are good. So I will start with first problem first. No, G is not a binary search problem. Probably square root decomposition if you want. I don't know how to solve F, so I will skip F, but I will definitely discuss C. So problem A says leap year. You are given an integer y between 1583 to 2023. Find the number of days in year y of Gregorian calendar. Within the given range, the year y has the following number of days. If y is not a multiple of 4, then print 365. If y is the multiple of 4 and not multiple of 100, then print 366. If y is a multiple of 100 but not a multiple of 400, 365. And if y is a multiple of 400, 366. And now there are different samples, for example 1800. Here y is a multiple of 4, but y is a multiple of 4 and 100 but not a multiple of 400. So 365 days. So the problem was pretty much implement the if else given in the problem statement. So pretty much these. So if y is not a multiple of 4, 365. Now in the else condition, y n must be a multiple of 4. So I checked if n is a multiple of 100 or not. If it's not, then 366. Now here n is the multiple of both 4 and 100. But if it's not a multiple of 400, 365, otherwise 360. This was pretty much the problem A. I will probably move to problem B. It says you are given an integer a of length n. Here a1 to an all are different numbers. Which element is second largest? So there are multiple ways to do this problem. One of them is you first iterate on the complete loop, find the maximum. Then you do a for loop again where you ignore the largest element and try to find the second largest element. And then you can print the index of it. Or another way around is you just take a, sort all the numbers, look at what is second largest number, and then find at which index second largest number exists and print that index. So that is the idea. Read all the numbers. Let B equal to A. Then sort all elements of B. Second largest, let's just say Bn minus 2. Now I can iterate on all the elements again. If B is second largest element, C out I plus 1. And yeah, pretty much this is the solution for problem B. Okay, we should look at A, not B. Any questions on the first two problem before we move to the third problem? So like there are many implementation. This is one way to do this. Definitely you can have different elements for ANV. Okay, moving to problem C. It says transportation expenses. There are n people participating in an event. The transportation cost of either person is AIEN. Takashi, the organizer of event, decided to set a maximum limit X for transportation subsidy. The subsidy of either person would be minimum of X, AI. Here X must be non-negative integer. Given that Takashi's budget is MEN, he wants the total transportation subsidy of all n people to be at most MEN. What is the maximum possible value of subsidy limit X? If the subsidy limit can be made infinitely large, report that instead as well. So like there are multiple, like first thing first, what it says is, one second, like my speaker. Okay, I forgot. So let me just take a sample as well. 1324. 1324. Let's just draw it here somewhere. Like 1 means only one coin. 3 means we have 3 coins here. Or probably like let's just draw some coins only. Only one coin. The subsidy someone needs is. Yes, the second person needs 3 coins to transport for transportation. Third person needs 2 coins. Fourth person needs 4 coins. Now let's say like the subsidy is X here. X equal to 2 subsidies there. Then what we can see is like these are the first 2 coins. Total budget required here would be like the number of coins in this area, which in this case is 1, 2 for here, 2 for here, 2 for here, which would be 7. We need a subsidy of 7 if our X is 2. Similarly, let's say if what happens if X is 3. Then the total subsidy we need is the number of coins in this area, which would be 1 for this, 3 for this person, 2 for this person, 3 for this person, which is 9. Similarly, if we have X equal to 1, the total subsidy we need is in this area, number of coins in this area, which is 4. And if X is greater than or equal to 4, if X is greater than or equal to 4, the total subsidy we need is like all the coins, like everyone will be free now, because 4 is the maximum value we need. And total subsidy in this case here would be 10. So we know what we know, that is if X equal to 1, subsidy we need is 4. If X equal to 2, subsidy we need is 7 coins. If X equal to 3, the subsidy we need is 9. If X equal to 4, the subsidy we need is 10. And for anything X greater than equal to 5, the subsidy we need would be 10 as well, because maximum is 10 here. So like now let's look at the budget for this sample. It says budget for this sample is 8. So what we can do is like we can have X equal to 1, we can also have X equal to 2, but we cannot have X equal to 3, because for this we need a budget of 9. We cannot have X equal to 4 or anything greater, because we want total budget to be less than or equal to 8. So in this case the answer is 2, like that is the maximum budget we can have. So any questions on the problem statement first before I jump on the solution for this problem? Okay, yeah. So now, like, there are multiple ways to do it, but I prefer the binary search approach. Like, you can probably do it without binary search, but we don't really need that. Like, the idea is like, you see, whenever we increase, like the way I drawn it is like, first time, like for if a person needs 10 coins, then I have drawn 10 coins in the 10 starting rows. So you see, whenever I increase X, the number of subsidy required will be increased. You can see, right? Like, let's say we have a function subsidy X, which gives us how much subsidy would be required when we take X. Then you can see subsidy 3 will be less than equal to subsidy 4. And similarly, this would be less than greater than subsidy 2, and subsidy 4 would be less than equal to subsidy 5, and so on. Like, can you realize why this would hold always true? Because here we are capping subsidy for each person by 3. Whatever amount he needs, if that's less than 3, he will get full subsidy. Yeah, subsidy X is the cost here. Or basically, like, the total cost we need if we want X to be 3. Here we need like that everyone can have at max 4 as the amount he wants. So you can see like why this function is increasing with respect to X. So you see, if I try to draw a graph of X versus cost or subsidy, it would be like this. Initially for 0, no one will get nothing. Now like it will keep on increasing for each integer. And at last, when X is greater than equal to max, it will be a graph like this. Okay, I am on problem C right now. So now like my idea is like we can even binary search here for the given budget. Like for example, if this is our budget, then we know that this is the maximum subsidy we can give. And if this is our budget, then we can have infinite as subsidy because sum of everything is less than our total budget. Or if this is our budget, then this would be the maximum X we can give. And that's what gives us the idea that we can binary search on the value of X we need. Like you can first check, like if you take infinity, like for infinity you can assume like every number is less than 10 to the power 9. So you just first check 2 into 10 to the power 9, if it gives you less than equal to m, then print infinity. Otherwise now you can just take 2 into 10 to the power n as the max budget you want. Like 2 into 10 to the power n is literally sum of all the values. And like there is one more way, like you can even binary search for the max of max budget here as well. Like if you, in general, if you don't know and if you have enough time, what you can do is you can just check if value of 1 is less than m, value of 2 is less than m, value of 4 is less than m, and you can keep going it like this. So like there would be some 2 to the power k when value of m would be greater than m if the answer is not infinity. Now then you can even take that value as the max value of r you want. So like that can be one way to find the max value, but like it's simple. Like you can just take sum of all values is less than equal to total budget we have, then print in infinity. Otherwise just take 2 into 10 to the power 9 as the max value you want, and that should be enough for the binary search. So this is my idea for this problem. Like I can show you the code as well. Like the first is take all the elements as input. Like some people decided to sort and everything, but that's not really required. Now it says check like if I have limit as the maximum subsidy I can give. This returns true if everything is within my budget, or it returns false otherwise. So I start with current cost. For X%, the cost would be minimum of X comma limit. If it exceeds the budget, return false. And if I was able to complete this loop, return true. Now idea is like I just took infinity, like you can also take 2e9. So even if you have a limit of 2e9 and you get like it is within your budget, just print infinity. Otherwise now this is your upper bound and now binary search here. So like I have some L2R, I looked at some mid value. If giving a subsidy of mid value is within my budget, I move my left pointer. If giving mid subsidy is outside my budget, I move my right pointer here, and like you see, like I start initially where left is 0, so it's possible to have that budget. Right is something where it's not possible to have budget. I find a mid. I see like on which side of left and right it is. Like because you see, like when we increase the value of X, like there would be some range up to which you can give some subsidy, and after which you won't be able to give that subsidy. And this was the solution for the problem C. Any questions on problem C before we jump on to problem D? Yeah, like you const T and D, you can do that. Like sum of array is less than equal to M, then print infinity. Otherwise, binary search from the answer 1 to max value of array or max value of array plus 1, something like that. So like you can choose anything. Like the important notice here is like if your subsidy is greater than max element, your subsidy will not change. Like if you like one thing you can see is like let M is the max value. Then even let's say if you choose X equal to M plus 1, then minimum of M plus 1 comma AI would be just AI. And this holds for anything over here. Minimum of I plus J for any J greater than equal to 0. And like that's the idea. Like you first take like if your subsidy is infinity, then you can give everyone whatever they want. So just check sum of values there. Now like what you know that if you cannot give everyone full subsidy because sum of everything is more than your budget, then you know that like if you give everything the subsidy of M, that is also equal to sum of everything, and you won't be able to take even that subsidy as well. Basically for X greater than equal to M, the subsidy is just sum of AI. So like you don't have to just choose maximum, you can choose any value which is greater than maximum. So in my case, I just chose 2e9, or even like I have a infinite constant defined which is greater than around 1e8 or something. Anything works. So just specifically choosing maximum is, you can even choose other value. Yes, so anything greater than maximum does not change sum of subsidy because we give everyone everything what they want. Yeah, that's the idea. So any questions on problem C before we move to problem D? So here like 5, 3, 2, sum of them is 10. And we have budget of 20, so answer is infinite. So one more minute for problem C, then I will move to problem. Problem D says Atcoder Jenkins tree. Takashi and Oki played a rock, paper, scissors and times. In this game, rock beats scissors, scissors beats paper, and paper beats rock. Oki's moves are represented by a string of length and consisting of character RPS. The ith character of S indicates Oki's move in the ith game. R for rock, P for paper, S for scissors. Oki moves satisfy the following conditions. Takashi's moves satisfy the following conditions. Takashi never lost to Oki. So like this is slightly confusing. And for all I from 1 to n minus 1, Takashi's move is in the ith game is different from his move in the I plus 1 game. So first, whatever Takashi is playing, he will not play two continuous same values at any point of time. And it also says Takashi never lost to Oki. Like Takashi never lost to Oki means he either had a draw or he won. This is not this does not mean that Takashi should always win. And like this is the slight difference over here. So like for example, we always play rock, rock. Let's say Oki is what this is what Oki plays. So in this case, Takashi like rock beats paper beats rock, right? So in this case, Takashi can play paper, rock, paper. But like this is valid way because here you will have a draw. But paper, scissor, paper is an invalid way. This is not allowed. Because in this case, in this game, Takashi is losing with scissor. So this is not allowed. But this is allowed. And the idea is DP here. Like, and then it says one more thing. Determine the maximum number of games Takashi could have won. It is guaranteed that there exists a sequence of move for Takashi that satisfies this condition. So the idea is we can maintain like DP, IER, means maximum number of games Takashi can play if ith move gives a rock. Similarly, DP, IS, maximum if ith move is S, and DP is drawn paper if ith move is paper. And like this is the DP idea. And at last we can just check DP and rock, paper and scissor to find what is the maximum number of games here. And like that's the idea for this problem. So I can slightly implement it in the different way. If Takashi is Oki plays rock, then Takashi can either play rock or a paper. Against paper, he wins. Against rocks, nothing happens. If it's scissor, then she can play scissor rock. And if it's paper, then she can play paper. What beats paper? Scissor beats paper. Paper beats rock, yeah. So like valid moves, let's call it valid moves. For each person, we know what they can play. If someone is playing rock, then against rock it would be a draw. Against paper, they would win. Yeah, backtracking with memorization will also work. Like what I did was iterative DP, but yeah, I can show backtracking also. Let's just write it in recursive way. Like this can be other way to do this problem. Yep. If we have passed all the indexes, just return 0. If dp idx dot count previous char, return dp idx previous char. Current char can be ok's current character is SA. So now the valid character I can have is, and if current char equal to the previous char, continue. We cannot play. Otherwise, we find what is the maximum value we can get with current char and idx plus 1. And if current char is not equal to previous char, like basically if current char is not equal to ok's character, then we won this game. Answer equal to max of answer comma. This would be the solution for problem D. One second. Infinity, sorry, we should take minus infinity. This passes everything. So like there was a question like what is run, storing, etc. Like you can probably check my one of the blog I have. What is Y Combinator? I thought I probably, yeah. You can just check, like this is one way to do recursion over here. Like, this is one idea to how you can do a recursion here. And like there I have mentioned like what are the advantages of doing. Yeah, so simple backtracking with memorization works here. So like the critical part is like you just assume that, like the critical part is like instead of writing it globally, you say that this is one recursive function which you can call from here. And yeah, like this is one way to do recursion. Like other way would be like I can write a global method over here and do the recursion, like that also works. So like run is my global function, like run is the recursive function which I am writing, or like some people might want to call it solve. So the idea is you probably just pass it on like this, and now when I'm doing solve, it can give me like backtracking solution here. Yeah, like the variable name is like this would be the same variable you have here, whether you call it self, run, solve does not matters here. So like here is what a Y combinator is kind of defined here. So like whatever method you pass gets passed on, etc. over here. Like this is just some boilerplate code here. So self, run, everything works. Like what we know is like this variable name would call the same function which we want here. Like you can just check the blog, like you can see like why I prefer Y combinator instead of the other ways to do recursion here. Yeah, just do normal recursion. Like you can read it how here, like to understand like why I am doing recursion this way rather than one thing. Like there are some advantages at some point of time. That's why I chose this way. So you are basically calling function recursively. Yeah, I am just calling it recursively, and like there is the notation I am using it is slightly different from what people may use by creating defining a global function, etc. Yeah, the problem here with recursion in Python is like you see numbers are up to 10 to the power 5. So like when you call recursion 0, it will call recursion 1, 2, 3, 4, 5, 6, 7, 8 up to 10 to the power 15, 10 to the power 5. And by default, Python only allows recursion of up to 1000 only. So you can use like you can call a method like this system.set recursion limit and call it 3 into 10 to the power 5 and your Python solution should work. That's it. Any more questions on problem D before I move on to problem E? So E says draw a sigma problem. You are given an array of sequence A1 to AN. Find the value of following expression. For all I 1 to n minus 1. For all j equal to I plus 1 to n. Find XOR of all sum of XOR of all the elements. Yeah, like in context I implemented iterative, so you can also find it in my submissions there. So we have been given this problem. Let's probably take some sample first. One, 3, 2. This is the array given to us. Like there are many ways to do problem E. And what it says is like for I equal to 1, these are the ranges you can choose. And for I equal to 2, these are the ranges you can choose. So like XOR of elements in the pink would be 2. XOR of elements in green would be 0. And XOR of elements in the Y would be 1. So total sum of these would be 6. So answer for this case, total sum of these would be 3. So answer for this case is 3. And like this is the first problem. So what it basically asks us is for every array of length greater than equal to 2, find XOR of all the elements. And sum them. And like the idea, first thing I have is like this looks a bit weird, right? If we allow length greater than equal to 1, then what we can say is like just give me length greater than means like sum of XOR of every subarray. So that's what I did. I first found sum of XOR of every subarray and then subtracted length 1 subarrays from it. So any question on the problem statement first? What the problem statement is asking us to do? So in this case, if I include length 1, these orange ones would be included. And the total answer I would get would be 3 I had initially, 4, 7, 9. So I can do 9 and then I can just subtract sum of all the elements 6, which would again be 3. So any questions on the problem statement before I jump on to the solution? So now, like, how do we find XOR of all the elements? Like, let's say we have this A1, A2. Let's first forget XOR. Let's first look at sum to begin with. A4, A5, A6, and so on. Let's also find, like, instead of XOR, I am looking for some prefix sum first idea. Let's say we have prefix sum. Up to 0th element, the prefix sum is 0. When you take first element, the sum of prefix sum is 1. Prefix sum means I mean sum of first I elements. So second element in prefix sum would be A1 plus A2. Third element would be A1 plus A2 plus A3. Third element would be A1 plus A2 plus A3 plus A4. And similarly, fifth element would be A1 plus A2 plus A3 plus A4 plus A5. And sixth element would be A1 plus A2 plus A3 plus A4 plus A5 plus A6. Now let's say we want to find sum of elements. We have an array like this and we want to find sum of elements from 4 to 6. Then what we can do is, like, we can take sum of everything and then subtract the sum of first 3 elements. So sum A4 to A6 is sum A1 to A6 minus sum A1 to A3. Can I say it like this? Like, if I compute like sum of first I elements for all the elements, then if you give me some continuous range from L to R, by just looking at 2 values, I can find sum of all the elements from L to R. So what I can say is, like, sum of A4 to, or like I can now say in general, sum of AL to AR would be sum of A1 up to AR minus sum of A1 up to AL minus 1. And this value is equal to pref sum R minus pref sum L minus 1. This works, right, for sum? And we have similar thing for XOR as well. What I say is XOR of AL to AR would be pref XOR R taken XOR with pref XOR L. Here the idea is, like, 2 minus 2 is 0 and 2 XOR 2 will also be 0. Like that's how XOR function works. And that's why instead of subtraction, I am just taking XOR here. Okay, like the idea is like if you take XOR of, if you are running some variable and if you take XOR of 5 two times, like the second 5 cancels the first 5. Okay, and like this is now the idea I have. So what I will do is I have an array A of length n. I will create pref XOR array which would be of length n plus 1 because I have to also take pref XOR 0 so that I can take sum of first I elements. Now what I need is sum of, like basically sum of XOR of every pair here. If I have now the prefix XOR, what I just need is sum of XOR of every pair in this array. And at last I will obviously subtract the sum of all the elements because length 1 is not allowed in the problem statement. Any questions on this one before I say the next idea? Yeah, like that is what I would be jumping now. Like how to have prefix or like you can have like the similar algorithm. You can just create a variable here of length n plus 1. And you also maintain a variable current counter or current XOR, call it. You read input, you take XOR with it, and you can just assign it here. That would be one way to assign count here. So this can be one way to like find XOR of every prefix here. Now like how to get sum for XOR of every pair, that is something I am yet to come on it. Like first thing I wanted was like jumping to this idea. Like our original problem has been reduced to this. Earlier we were having some ranges, now those ranges no longer exist. So if you have followed me up till this and if there are no questions on this, then I will jump on to like how to find XOR of every pair. So like, so numbers are up to 10 to the power 8, which is less than 2 to the power 30. So what I can say is like for every bit, basically like let's first look at XOR table. X, Y, and X XOR Y. And let's say what happens with the ith bit. If ith bit of X is 0 and Y is 0, final bit is also 0. If ith bit of X is 1, Y is 1, the final bit here is 1. If ith bit of X is 1, Y is 0, this is 1. If both of these bits are 1, then the final bit in the XOR is 0. So like now, like if you look at this XOR table, you know that what we need is, if we know count of 0 ith bit in pref XOR and count of one ith bit in pref XOR then we can count like how many pairs would be like this, which would be count I 0 into count I 1. So like I can say like in final value this multiplied by 2 to the power I would be contribution of ith bit. And like basically what I am doing is I am looking at bitwise contribution of each bit rather than trying to find it in one go by looking at all the bits. So one bit at a time, like for 0th bit, I would count how many of zeros are there, how many ones are there. And then I can count like how many pairs will have one of the element 0 and one of the element 1. That multiplied by what bit it was would give me the final answer. So like let's say current XOR. This would be my current XOR. Like I am now counting. Okay, did not understand the contribution part. Yeah. So let's write a number like this. Like probably, let me take one example here that should solve. Let's take 10 and 4. Like binary notation in 10th would be 0, 0, 1. 10 looks like this. 4 looks like this. 10 looks 0, 2. This is how binary representation of 0 and 1 is there. This is 0th bit, first bit, second bit, third bit, fourth bit. And their 10s or 4 is, this is 0 and 0, so this bit remains 0. This is 1, this is 0, so this becomes 1. This is 0, this is 1, this bit becomes 1. This is 1, this is 0, this bit becomes 1. Let's to simplify, make it a bit simpler, let's just take both of these as 1. So let's take 11 and 5 here. So 11 or 5 would be, bit would be 0 again. And now if you look at this value becomes like 1, like first bit, second bit, third bit is on. So 2 plus 4 plus 8, which is around 14. So this value is 14. And that is my idea. Now instead of trying to do it in bulk, I process here bitwise bit. I see like if I look at all the numbers, how many ones would be there here on each pair. Then if I look at all the numbers, how many 0, 1 combinations would be there for this bit. That count multiplied by 2. Then if I am at the third bit, I see how many 0 ones would be there for the third bit multiplied by 8. And that is the idea I am doing. So any question on contribution technique, like why did I came to contribution? Because when you look at how XOR of two numbers works, that happens at bit by bit layer. Yes, I am doing it only with pair of numbers. Because like I initially like boiled down problem to like I need sum of XOR of every pair by using prefix some idea there, prefix XOR idea there. So initially I had a range, but I boiled it down to given an array, give me like sum of XOR for every pair. So that's the idea I have. So any questions, and like this essentially solves the problem here. Like I can show you the code here. Like I was completing the code. Like number of bits I just took at 40. You can take anything. If jth bit is 1, then 1 count j plus plus, and 0 count j plus plus. Now the idea is number of elements with jth bit as 0 would be this, and number of elements with jth bit as 1 would be this. And here like power 2 would be 1 LLJ. So I can now do answer plus equal to one of the elements should be 0, one of the elements should be 1 multiplied by what was the power 2 I got. And this is my solution for problem. The solution is really small. And like because now I have to also remove sum of all the elements, which I forgot because we want. Okay, I do not have the answer. Like I should also take VI. Or like I can just call it an array of length and so this is my solution for this problem. Any questions on problem B before we move to problem G? Yeah, this fast. Any questions on problem B? Like G would be the last problem I would discuss today. By the way, to answer that question, what if we have more than two numbers, right? So there the idea is like number of bits which are odd times would have 1 finally, and number of bits which are 1 even times would have 0 finally. Okay, let's move on to problem G. This would be last problem for today. N people work at the Atcoder office. The office keeps record of entries and exits. There are M entries and exit records, hence the records are beacon. The ith person is represented by pair Ti Pi, indicating that at time Ti, person Pi has some entry. Like if person was inside, he went outside. If person was outside, he went inside the office. If they were outside, and yeah, that's the idea. It is known that all the people were outside the office before we started taking the records, and after we have taken all the records, everyone is outside the office as well. Now we have to answer qth query. In the ith query, we are given pair AI BI, and we have to find total length of time, total number of time when both the persons were inside the office, and that's the problem statement we have. So like this is some sample. This is at time 10 some person 1 entered the office, and like at time 2 person 2 did something, at time 3 person 1 did something again because he was inside, so now he is outside. Now 40% 3 60% 3, so at 40% 3 entered, at 60% 3 exited. Then at 70% 1 did something again, so this time he is entering because he was outside. At time 80% 2 did something because he was inside, he is outside now. And at 90% 1 did something, so this is the case. Now problem 1 asks what are the times when person 1 and 2 both were inside office. So this plus this 20 is the answer here. What was the time when 1 and 3 were together in office? You can see like when 1 was inside, 3 was outside. When 3 was inside, 1 is outside. So total time when both of them were inside is 0. And then 2 and 3 again. So like this would be the time when 2 and 3 both are inside. So answer is 20. So like square root decomposition is something you should read about it. Then there are different ideas for it. But the first critical idea is square root decomposition here. So this is the problem statement. Any questions on the problem statement first? So like assuming that there are no questions, I will jump. Like there are two ways to solve this problem. Like let's first also assume that all the times are between some 1 to 10 to the power 6. Let's not take it very large, 10 to the power 9. Let's say everything is between 10 to the power 6. Like that will make my explanation a bit easier, but that's where we are. And like switching it to 10 to the power 9 does not require much idea. So there are two ways to solve this problem. Like let's say for each person we know like a sorted interval of ranges when they are inside office or not. So for example, in the first example 1, 2, 3, person 1 was first inside between 10 to 30, and then he went inside office from 70 to 90. For person 2 this range is 20 to 80, and for person 3 this range is from 40 to 60. So one thing we can do is like we can run a for loop like this. I equal to 1 to n. Then we have a long array of length 10 to the power 6. Pi 10 to the power 6, which like pi is 1, or like probably if I is confusing here, like then we can take px. We have a long array. Px is 1 if at time x ith person is inside, and 0 otherwise. we can definitely do this, right? Like for create a long array of length 10 to the power 6, and for every point you can either run a for loop or something, whatever you want. Like for every range, you already know the ranges when someone is inside. And then you can also use prefix sum on P. So that you can, given some any L2R, you can find total number of seconds person was inside it. I was inside. This works, right? Like first I am just doing a plain brute force here. What I am doing is for each person, like the idea is I will run a loop like this. For I equal to 1 to n, for j equal to I plus 1 to n, find the total time here using brute force. And to prepare for this step, to prepare for this for loop, I am doing some ideas here. What I am doing is like using some prefix term and when some person was present. What I am trying to do is like now if you give me any range from L to R, I can answer you when person how total time person I was inside it or not. So if I have done this preparation, now I can run a for loop from j equal to I plus 1 to n. For each interval person 1 is count using the previous prefix sum what was the total time sum was inside. And total sum would be my answer here. Like let's say here person was inside between 30 to 40, 40 to 50, 90 to 110. So you can use this prefix vector to count total overlap in this time, total overlap in this time, total overlap in this time, and sum of all of them would be your total time. This will definitely give me a TLE, but you can see like this should give me correct answers. TLE is fine, but it will not give me wrong answers here. And if I try to estimate total time complexity here, we would create n times, we would run a for loop n times for finding the prefix sum, and length of that prefix sum is 10 to the power 6. And then we do it for all pairs as well. So what I am saying is n into m, or probably m by 2 you can call it. Like basically m is, let's say, m into q equal to number of ranges, which is m by 2. Roughly this would be my time complexity for this solution. Because like q would be the number of times when you will count how many prefix, like q would be the number of queries on your prefix sum array there. This time complexity is for building that prefix sum. This is the number of queries you would need for comparing with each element. Q by 2 or something, like there would be some on and off over there, like some constant multiply by half to some would be there, but this would be the overall idea. Any questions on this part? And what I say is like in original question problem statement, it would be 10 to the power 9. Because elements are up to 10 to the power 9, so you need a prefix sum array of 10 to the power 9. And I will skip this optimize here and just say you can use coordinate compression. use coordinate compression on prefix sum to make it length m, yet store sums up to 10 to the power 9. I will probably skip how to do it. But yeah, one quick recap. Yeah, definitely let's do it. So my idea is I will run two for loops for I equal to 1 to n, for j equal to I plus 1 to n. Before running this for loop, I will prepare a data structure which takes some range L to R and gives me count of times when person I would be inside. Prepare, like when I am running prepare data structure which takes time, gives us count of times when person I is inside between time L to R. Let's say I have some this a data structure like this and it also gives me in some order one time. And if I have prepared a data structure like this before the start of this j loop, then I can look at for each jth person all the intervals when person j was inside, and for each j I can count for each range of j when person j was inside. I can count how many times I was inside, and sum of all of them would give me my final answer. And my claim is overall time complexity here would be around order of n into q. This is the best you would be able to do. You can't do anything better than this. Like some preparing of data structure, everything is inside, but this is the best you can do here. Like I can also write a brute force code for this one. Like code is quite long, but let's do it. We find count of j times same data structure. Yeah. Like for every j we have here, for every j, I am counting like how many times person I was inside. And first I have like, so for example, when I have prepared data structure for 2, I can directly count how many times person was inside from time 20 to 80. That would give me 20 and I can directly say 20 is the common time. For person 3, I would like that data structure from 40 to 60 would give me 0. Let's say if there was one 85 to 100 here, then I would have first queried for 20 to 80 and then 85 to 100. 20 to 80 would give me 20 and 85 to 100 would give me 5. And this is, you see, this is one of the brute force idea, and like if you use just this idea, like among doing a lot of optimizations, coordinate compression, etc., the best complexity you would get would be n into q. You cannot do better than this using this. And here n is up to 2e5, q or basically number of entries would be m by 2, which is 10 to the power 5. And this would definitely be a TLE solution. This is one brute force to solve this problem. I will say one more brute force first before jumping on the solution. We can also use the two pointer idea. Let's say we have these are the times of psi. These are the times of person u, and we have a person v which looks like this. And like these ranges are definitely sorted. Like data structure, that would be simpler, but we cannot. I am not optimizing on the data structure right now. Like order n into q would be the best you would get even if you get the best data structure to answer those queries. So like you can't have anything better than order 1 for the data structure. Like I can briefly say that, but that's where we are. So I am jumping on to a new solution. What I am saying is when you ask me for u and v, I will list out all the ranges when u and v are there. And what I am doing is trying to do is do a two pointer algorithm here. Initially I am on this range and I am on this range. I count the overlap of these two ranges, which would be something like this. Add that overlap to answer. And because this range closes before this, now move this green pointer here. And this pointer is here only. Now you again look at the overlap of these two ranges, which would be something like this. So add this overlap to your answer. And this time this white interval ends before blue. So now move this white interval here. Now you are at these 2 points. There is no overlap between them. Add 0 to your answer. And then move this pointer here. Yeah, it's similar to merge part of merge sort algorithm. And now when I am here, this is the overlap we have. Add this to your answer and move this part here. Here like this would be the common range you would have. Like if you have two range from L to R, L1 to R1 and L2 to R2, using some if else in order 1 you can count like what are the common elements between both the ranges. And the idea would be now move green pointer here. There is nothing common between these two, so add 0 to your answer and move your pointer here. Now for these two, this would be the common part. Add this common part to your answer and move this part here. This would be your common part. Add this to your answer. Now this green would be outside here. So break now. This can be another way where you would find like total overlap of every person here. And the best, like if I keep my all the pairs of u and v unique and I keep taking maximum, again like the best I would get would be some like, let's just say there are only two people. First person moves m by 2 inside, m by 2 like, or probably q by 4. First person has q by 2 ranges. Second person has q by 2 ranges. So overall, or probably like, let me do something else. If youth person has RV ranges and with person has youth person has RU ranges and with person has RV ranges, then total time complexity of this algorithm would be RU plus RV. And you can't do it better than that because you will have to look at each interval for both the person at least once. And what I say is like you can construct if you use just this algorithm. Then like total time complexity would still be n into q or something like that, like the same complexity as previous. Like even if we found something new here, like we have not improved our time complexity, this second solution will also give me TLE. So far I have two solutions. Both of them are TLE. And I cannot do anything better over here. So now I have different idea. Pre-compute. Let's define some constant. Let's define a constant b. Pre-compute. Use first algorithm. To pre-compute answers. For all people that entered more than b times. Like earlier I was doing that solution even for some person has entered one time. What I am saying is use first algorithm to pre-compute for all the people that had entered more than b times. So if you have query u comma v, if any of them has entered more than b times, you can directly say the answer. Directly print the answer. Otherwise, use second to find answer in some order b plus b time. No, like we cannot optimize the second solution with any way. Like the best you would get is q into n. You can't do better than that. Like just take each pair every time, and like first time you ask any two pairs which are maximum values, then maximum and second maximum, maximum, third maximum, anything. Like that two pointer is there, and that cannot be done better than q into m. So no optimization over there. So like for each query you would need to visit any range which is present in any of the element at least once to look into it. So now what I have done is I have two solutions. Both of them gives individually TLE. What I am doing is I have defined some constant b. What is the value of b? We will come back to it later. But now what I am saying is when if any person who has entered more than or greater than equal to b times, I will pre-compute answers using first algorithm. No, I don't mean print b. What I am saying is like this was one algorithm which I said that can pre-compute answers for every pair of people we have. What I am saying is like just run this I only if a person I has entered more than b times. And so like other person may have entered less than b times, but this algorithm does computes that as an answer. So if a person I has one of the person, like if u has entered b times, just look at the pre-computed answers with u. If b has appeared more than b times, just look at pre-computed answers for b and you will find your answer in one of them. And if both of them have entered less than b times, then use the second algorithm I have shared with you. And like the second algorithm just looks at each range over there. So we had like number of times you had, time complexity was number of time person u has entered, number of time person v has answered. Because both of them has entered less than equal to b times, the time complexity per query would be order b. So, and like now, if like this is how I am combining both solutions. So like of first type, this is the maximum count of people that can enter b times. And like this would be the overall time complexity I would have, like for pre-computation. And any query which involves this would be answered in order one time. And for second query, like there can be q queries. Each query would require around order b time. So this would be the time complexity for the second part. And like you can see in problem statement, q is up to 10 to the power 5. So now if we take around b, which is equal to square root of q approximately, then this time complexity would change to q into square root q, and this complexity, time complexity, would also be q square root q. Like b is a variable, we can choose anything here. What I am saying is if you choose it approximately equal to square root of b, why q by b? Like, oh wait, it should be n. No, it's q. Like q is the total entries, total number of times, total number of times people have entered. So if we want to count how many people have entered at least b times, this is the maximum number of times, number of people that can enter at least b times, not more than that. Like for example, I know like people have entered an office 20 times, and you ask me like how many times people have entered 3 times, I would say 20 by 3, 6. You can have at max 6 people that can enter office 3 times, because 7 people need at least 21 entries to enter here. So that's how q by 2, q by b we got it. And this was total number of entries, because like this would be the number of times you would be asking from the data structure, give me in this range how many times this person has entered. Like these are the number of times you would ask data structure. Like for each range of each person, you won't ask multiple times. Like you will ask number of times like your I loop runs. This is total time for J loop. Like the number of times you can ask data structure for this range, count how many times this person is present. And this is the number of times your I loop runs. And for second part, this is the number of queries you can have, and each query would take not more than this much time. You can also say it to be 2b, that also works. And now what I am saying is like b was variable here. If you take b approximately equal to square root of q, This complexity would be q square root q. This complexity would be q square root q. Q you have around 10 to the power 5. So q square root q is around 3.2 into 10 to the power 7. And this is the final piece. Like if you combine these two solutions like this, you will get an AC. Only first solution gives you a daily, only second solution gives you a daily. But if you combine these two approaches based on an if condition, you will get an AC. And this idea is known as square root decomposition or like square root technique. Square root technique. Like basically come up with two solutions, both of them gives you daily, but if you combine both of them, you get an AC. You can find square root decomposition is slightly different from square root technique, but the idea involved there is also similar. So yeah, you can check this Rector's blog. He has also a lecture with timestamp. You can just use this to practice. So like a lot of complexity is still involved there. Like how do you design that data structure which takes ranges up to 1 in 9 and gives you in order time how many times some number is present? But that I will probably leave it. Like my suggestion would be solve this problem assuming all the ranges are between 1 to 10 to the power 6. Like there the idea is prefix some like so like that essentially involves like the prefix sum which we discussed earlier along with something known as coordinate compression, and you can play around both of these to get what you want there. But yeah, probably that can be a small follow-up. Like I think that part would be easier than the complete problem. But you can, if you don't understand, just let me know in the comments. I can probably try to answer it in comments there. And like a brief overview of the solution which I wrote. Like in practice, I needed up to 500. Just square root of 1000. Taking it as 320 was giving TLE on two solutions. So like here I am taking all the times when person P was present. Like you can just maintain like present I if person 1 is inside and remove. So if you have T and P, if person P is inside, then you know at what time he entered, and this would be the range when he would be present there. And now remove that person's entry. Otherwise add that person into the time. Some these coordinate compression etc are there to answer those queries in order 1, but probably let's just skip it. Now I have this dp vector which just looks at like have I pre-computed answers for I and v before. So this solves take if I have already pre-computed answers for this pair u to v, directly return that answer. Otherwise use the second algorithm I shared to find the times when person b was inside and return this and just save it in the dp whatever vector you want. The idea is like now I am just like I am just filling up these values with all the person which has answered r times r is equal to b, which I discussed earlier. So basically just absurd all the answers for person j if person j has answered at least b times. The idea here I am doing is like some prefix, some optimization, some weight, some optimization, etc. The key idea is like within some constant range I can find for a particular range when how many times a person b has answered. So the idea is for like prepare the data structure here which can give you in order 1 how many times a person has entered from L to R, and this essentially also removes the previous computations for any other person I have. Now go for all the person from I to N. If I have already computed it with person O and I, just ignore it. Otherwise, look at all the times when person I was inside. Count how many times in this range this person L is inside, and just store that as your answer. And this was the solution. Like I have probably rushed a bit over here, but essentially this is the crisp of the solution. No editorial here, but yeah, like it's doing something. Size of both is less than equal to C. Like you use that idea. At least one of them is C. You pre-compute and get the time complexity like that. That's what the solution is doing. If large limit is this, and yeah, memorize etc. is there. Yeah. So this is my idea for problem G. And any more questions or anything related to even like in general, I would be happy to answer them. And yeah, this essentially completes my stream for today. Like I said, like if you look at the time complexities here, one of the time complexity was q square by b for pre-computation and q into b for the second computation. So if we write this as f of b, then if you want to find the maximum value here, you just take a derivative here. F of b would be minus q square by b square plus q. You set it to 0. You would, simplifying here, you would get b equal to square root q. So if you take b is equal to square root q, you would get the minimum value of this function. And that's what we want. Like we have two algorithms. We want, if we combine both of them, we want the time taken should be minimum possible. So that's how I took q equal to square root q. B equal to square root q. Like if you take b equal to just 50, like you won't improve much. If you take b equal to 50,000, you won't improve much. But if you take around 325, and sometimes you may have to play around with values, like like the approximate value should be square root of b, but like that constant can slightly vary. So you can, like in the feedback system like Atcoder, you can just submit multiple values from 100 to 1000, 2000 to get the solution you want. And even in code forces, you can try out multiple values, look at time taken, and slight of assume that the total time in pretest is equal to all the time, and that should solve the problem. So yeah, like this completes my stream for today. Thanks everyone. Like if you have any questions, you can ask me. Otherwise, And thanks everyone for joining, whoever is here so far. I think I will probably keep a minute or more and then end the stream.